Let's do the rest of the questions. So question 9 says, you're running a political campaign in which to estimate with 90% confidence the proportion of registered voters who would vote for your candidate. So kind of like the same situation I gave you guys in the very beginning of this, right? What is the minimum sample size? So looking for n sample size, right? You are if you need to obtain with 3% of the population. So accurate within 3%. So we do proportion, right? It tells us it's proportion. So it's going to be one of these two, right? So the question now is, okay, are we given how many people are registered voters? Hopefully say no, right? And again, it doesn't give it. So again, p hat not given. So in other words, we're going to do the same equation we just did above. So n is going to equal to 0.25 times our z-score. Since we want 95%, that's going to get 1.96. And then what's our margin of error? 3%, right? So that's going to be 0.03 and then squaring it. Okay. So once we have this, and if after you round, you should, or if you round up, you should get 1,068. And there we go. Okay. So now let's try 10. So once you guys try 10 over here, so I'll give you guys a quick pause and then try. So 3, 2, 1, pause. Okay, so now let's try it together. So assume the CEO of eBay wanted to determine the number of people who use the internet. He wanted to get a 95% confidence interval with an error that is no more than 3%. So kind of like the same scenario above. A says, how many does his people need to survey when 73% of adults use the internet? So we want how many people, right? How many people is sample size, right? That's the portion. So are we dealing with mean or proportion? Well, they gave us a percentage, right? So that's proportion, p hat. So again, that goes back to one of these. Are we given it or not, right? So since we want the people who use the internet, well, are we given how many, the percentage of people who use the internet? Yeah, right, 73%. So this one p hat is given. So we're going to be using the first equation we have there. So n is going to be p hat, which is 0.73, times q hat, which is just 1 minus that, so 0.27, times, well, our z-score, 1.96 because it's 95%, divided by margin of error, which is 3%, so 0.03, squared it. So dividing, then squaring, then multiplying should give you, and then after rounding, approximately exactly 842 people. Okay. And then for B, it says, if he did not know the percentage, so in other words, p hat is not given, so it's the same scenario as we did above, 0.25 times 1.96 over 0.03 squared, right? So notice the only thing that changes if p hat is given tonight is the numbers in front, right? Everything else is exactly the same. And in this case, after you round out, it should give you 1068 as well. Okay. So let's go on to the last question here. So doctors at a hospital want to determine how many patients need to have monitored in order to have a death rate of 12% with an error as low as 1%. Okay, so that's a situation. A says here, how many patients does the hospital need to monitor to have a 12% death rate with a confidence interval of 99%? All right, so it's still proportion, correct? We have a 12% portion, so 12%. So it's p hat, so our p hat is 12. So therefore failure is with minus that, so 0.88. Okay. We want 99%, so our z-score should be 2.575. Right, just going to look in our table. Okay, so therefore, if we keep going, so it's going to be n is equal to 0.12 times 0.88 times 2.575 over. Now, what is our margin of error, though? Our margin of error was what? as low as 1%. So 1% in decimal form is 0.01, and then squaring it. Okay. So once we get all this and slowly breaking it down, you should get, and then, obviously rounding up, 7,002 people need a monitor. Okay. And the last scenario is, well, what if they did not know the death rate percent? In other words, p-hat is not given to you. So therefore, it's going to be n equals 0.25 times, well, same z-score, so 2.575, same margin of error. And then this time, however, once we multiply and round, you get a much higher one. It's almost double, right? 16,577 people in this case. Okay. So the last scenarios is going backwards, right? Finding the sample size itself, right? And remember, sample size, it doesn't have to be people, right? It can be objects, data values, anything, but you're always finding sample point, meaning going backwards. And you have to identify, are you given mean or proportion? And if you're given proportion, you have to identify, is p-hat given to you or not given to you, right? Because that, this drastically changes your answer as well.